All right, hi Eli. So I'm just going to go through the questions from 6.2 in this video, and then I'll make another video for 6.3 for you. So the first question you had asked about was this one here. I covered 5 and 6 for you already with the A values, just knowing about the negative and the positive, indicating the direction of the opening. So with this one, it's asking you, if you look at this graph here, what could be a possible value for A? And actually, this is like a little bit of a tricky one because there's nothing to compare it to and you have no other information about this quadratic function. So I wouldn't worry too much about this one in the sense that I wouldn't give you a question like this on a test. I'd be more likely to give you a question like if you look in your textbook on page 353, question 4, where you're given 4 different graphs and you have to match them to the equation below. But the nice thing with those graphs is that they actually give you a chance to, I'll maybe put it up here a second so you can see what I'm talking about. You can actually see, so it's this question here, you can actually see some of the different graphs that would be possible, and then they give you the equations here. And so, for example, like I mentioned to you in the previous email, positive A values are going to be opening upwards. And so with this one, we know that A and D are both going to have positive A values, so that could only be 2 and 4. The other thing we also know from looking at quadratic equations is that the C value, so right, because your A value is here and then your B value is here. If you don't have a C value, that means your y-intercept is 0. If you have a C value like positive 6 here, that means your y-intercept is going to be at 6, right? So those are things that can help you to identify things on the graph. And then also, the width of the graph can also be affected by the A value. So you can look at all of these different things kind of together to basically figure out which graph goes with which. And because you can compare them, it's also helpful. However, in this question that we were looking at in the workbook, they only give you the picture of the graph, but they don't tell you any values. So you can see where the y-intercept is here, but that might not necessarily be super helpful because all we're told is that we have the function. They give you the general format, right? So the big thing here would be you know that because it opens downward, the A value has to be negative. So that does narrow your choices down to A equals -3 and D equals -1/3. Now, the thing that you would want to keep in mind is if your A value is greater than +1 or less than -1, it starts to get narrower. And if it's less, between -1 and 0, or between 0 and +1, so basically if it's a fraction like this, then the graph starts to get wider. And so because this graph is more towards the wide side, I would choose D. But because you have no frame of reference, I find this to be kind of a tricky question, and I wouldn't give you a question like that on a test. So if it's still kind of throwing you off a little bit, don't worry too much about it. Okay, the next question you asked was for 11, I believe. Let me just double check. Yeah, question 11. So this one right down here, and it says the points -1, 12 and 7, 12 lie on a parabola, and we want to figure out what the equation of its axis of symmetry is. So in the textbook, it did give you a formula for solving for the axis of symmetry based on your x-intercepts. However, with this set of values, we don't have x-intercepts, so we just have 2 points on a graph. So basically what I would do is I would kind of say, okay, if I have my graph, I want to think about where these points are. Actually, that's not super well. So I'm just going to, both of these points are on 12 12 on the y-axis, right? So I'm just going to label this line here. Instead of thinking of it as 0 for y, I'm just going to label it as 12. And then I know I have a point at -1 on the x-axis, so -1, and then a point at 7. So I go 0, 1, 2, 3, 4, 5, 6, 7 is my other point, okay? And remember what an axis of symmetry is. It's basically the line that's halfway between 2 points anywhere on the graph. They don't actually have to be on the x-axis. And so if we look at this one, because we go from -1 to 7, we have 8 points separating, so halfway in between would be 4. So 1, 2, 3, 4. This is halfway between these two. So regardless of how your parabola is going, whether it's going like this, or maybe the other way around, or whatever, this line is going to be halfway in between, and we find that that point is at, if we have 0 here, 1, 2, 3, x equals 3. Okay, so sometimes like you don't have to always worry about memorizing all the formulas and stuff like that, because you can just kind of, if you can just visualize the graph and think through it, you can solve for the question like that. Okay, so that's question 11, and then the next one you had was 13D. So in this question, first of all, we have, we're given like y equals x squared minus 5x, and we're told that it passes through the point 0, 0. So it basically passes through the origin. And before you get to part D, you determine a bunch of things. So you determine the other x-intercept, which ends up being 5, 0. And what else do you have? The equation, the axis of symmetry you solve for, so that was 2.5. And I'm assuming because you didn't ask about any of those that you got those fine. I'm not going to worry about the vertex because that doesn't really help us out for our part D, but these two parts do. So this is our other x-intercept, and this is our axis of symmetry, so 2.5 equals x. And in part D, it asks you if we have y equals -3x squared plus 5x, and it has the same axis of symmetry as the previous graph, so x equals 2.5, we want to solve for what is the value of k. Okay, so basically we have this axis of symmetry being at 2.5. Again, whenever you have a quadratic formula, if there's no c value here, we know that that means the y-intercept is at 0. So we know that there's a point 0, 0 on this graph. Okay, we can solve for the other like the other x-intercept because we know what our axis of symmetry is. So basically we know with this graph, we have a point here at 0, 0. And then we have an axis of symmetry at 2.5. And then we have, so where would our other x-intercept basically be? Well, if this is an axis of symmetry, then it has to be from this point to the other point. It has to be the same distance as here. So from 0 to 2.5, it's 2.5. So then from here to the next point would have to be another 2.5. And so that would put this at a total distance of 5, 0. So basically that means it has the same x-intercepts as the previous question that we did. So now that we have a point on the graph that we can use, we can basically go in and plug these values in to our equation to solve for k. So now we would go back and say, okay, when y is equal to 0, x is equal to 5. So we're going to have -3 times by 5 squared plus 5 times by 5. Oh, wait, what did I have? Oh, not 5 times 5, k times 5. I was wondering why that seemed weird. Okay, so k times 5. Okay, so then we just simplify. So negative 5 times 5 is 25, times negative 3 is negative 75, plus 5k. And then we want to start isolating our k value. So we're going to move 75 to the other side by adding it. 75 equals 5k. Then we need to get rid of this 5, so we'll divide that out of both sides. And we're left with k is equal to 75 divided by 5, which is 15. So there's our value for that one. Okay, so those were all your questions for 6.2, so I hope those will help you out, and I will send you along a video for 6.3 shortly.